Hey, all right. That's better. That's better. Okay, great. Hey, Keenan, are you better?
I'm feeling a little better, but I'm still not very presentable.
Yeah, who cares about presentable? But but you're in. You're feeling okay.
Uh,
No, so well, a little better
better,
anyway.
better, yeah.
So that's great. Yeah, yeah, yeah. As long as the slope is positive, you start feeling better too. That's great. Um, Yeah, so yeah, I think other people are sick. Many people are sick yeah, and so I think you guys should just feel free to ask me if you're sick, saying, "Hey, can I get a bit more time here, there, and so on and so forth." I'm happy to consider all those requests, okay? Because I'm just following every time you take a stab at something, I can see it. And so if you're putting in the effort, um, I uh, I am 100% behind you to keep pushing you as much as you need. So if you were sick, um, you should just let me know. We have time. Theoretically, I think the state. Well, if the state. I don't know if there's a requirement, right? Theoretically, there is the limit is the last day of the quarter for any instructor to accept all work. And the reason we don't do that is because then it becomes very, unruly, and nobody does anything until the last minute, and it's all messed up. However, that being the case, I don't believe there is a single instructor, at least I don't know of any at Foothill, that wouldn't consider a genuine request, right? Saying, hey, I'm really interested in the subject, but I can't do any of these until maybe 2 days before the final exam. But I assure you that I'll send you email or something. You can see that I'm, um, if it's a genuine request, I don't know. And every person, every instructor that I know would consider that. So feel free. So our goal at the end of the day is for you to learn the material, because why else would we be teaching this? Yeah. So, and however you do it, I don't care. Yeah. That's why I said, when Keenan says not very presentable, who cares? Right. So, we're not your appearance evaluators. So we're all here on with the same mission to learn the intricacies of this mystical, not mysterious, programscape called C++, inside of which there are so many adventures, yeah, and rich nuggets to be found. So I'm just showing you the landscape here and saying, here's how you go, and this is, and because this is a new country, that you guys are probably experienced travelers, but you also need to be experienced in life in a certain way. What I mean is that you need to be robust to many frustrations, not all frustrations, but many frustrations, because if you're not robust to, that's what I mean by life lessons. Because when we don't have these lessons, we get frustrated by little things like candy dropping on the floor and things like that, right? But as you get these lessons, we say we get more and more robust to basic frustrations, and then we can face the bigger challenges, because the basic frustrations are become second nature to us, automatic. We don't even relegate conscious thought to this anymore, right? So because we know if something happens, yeah, well, it's just a matter of time before we can reverse it, and it's just x 0.23 effort, right, to get it back to where it is. And I know how much x 0.23 effort is because I've done that so many times. And and like that programscape, okay, so we are in cs2a, where I'm basically showing you, well, folks, you had a fantastic run with your life so far, and you're looking for a new experience, a new adventure, right? And rather than rather than give you a pill or something saying, all right, take this and you'll get a new experience, right? So I'm saying here's an alternate way. It's exactly the same, right? No different from something else that well, this is probably more useful to your real life, right? And if you are attuned to it. So I'm saying here's a brand new scape, right? So I call it Questscape, or you could call it Programscape, or it doesn't even have to be on Quest stuff, right? So, so this is this new arena that I'm introducing you to, and it's C++. And here I'll show you there's so much fun in this here, right, in Disneyland. However, you need to abide by the rules of Disneyland, or they're going to kick you out. Right? Well, Disneyland is a good land, like BASIC or some other language, right? So you're already, you've gone to Disneyland and you're strong enough there. Now you're saying, all right, no, I want to go into the more adventurous lands. Like, if you're playing these adventure games like RuneScape and things like that, and you wander into the wildies, yes? So I used to play it a long time ago, so that's why I know these things, right? So you wander into the wildies, you're saying, I'm looking for real adventure here, right? I'm willing to meet barbarians. And however, the risks are higher, right? I'm not just going to be kicked out of the park. I'm actually going to be murdered, right? Or worse, if I get caught. Yes? So that kind of area in the wildies in RuneScape, and saying, see, well, here it is. That's the layout of the land, and you'll find all these incredible treasures in this wildies. Okay. However, this is a controlled kind of wildies where other people before you have boldly gone and died and left their skeletons to mark the places that are dangerous. Okay. So what I'm going to tell you as a guide to this new country is, well, welcome to this new land. All right, there's so many fun things to be found here. Hey guys, you got to switch on your cameras, okay?
Yeah,
Yeah,
just
all
give me
right.
like 5 minutes and I'll
understand.
turn
I
on my
understand.
camera and close the
I'll
camera.
be speaking. No, that's fine. Yeah, as long as you're speaking, that's fine. Okay. Keenan was speaking, but Kai and June are not speaking. So you got to
my camera in like 5 minutes too.
Okay, all right, Kai, I can hear you. But really, that green rectangle that lights up these, icons, it doesn't move in the recording. It only moves in the live Zoom session. So in the recording, you just have to see people's lips moving. And then if there's a voice coming out, I don't know which rectangle. If a future student is looking at this, right, they don't know who's speaking. And it could be one of the black squares. Yeah, and in fact, even the names don't show up. It's just black squares, I think, or gray squares or something like that, and not even initials or anything. So there you go. Hey, thank you, Kylie. Yeah, and so it actually helps a lot of people just to have the camera on. Besides, also making the recording worth clicking on. Otherwise, people are not even gonna look at it. Anyway, what was I saying? Yeah, this new, I'm saying this is the, but however, this is, although there are incredible prices that you won't find in ordinary lands, in C++ land, you won't find them elsewhere. You can find them here, but if you want to go in here, you have to know it's wildies. And so you got to know where you shouldn't go, or, you got to know what the consequences are of going to places where you see a lot of skeletons, right? So I'm the guide who warns you in C++ land by taking you around to some of the dangerous paths, but I know what the hell is going to happen. You're going to skid and fall and suffer for bruises, but I'm going to be around saying, okay, well, you get a taste of C++ land, but however, you're still willing to stick around with me because you think there's even more treasure to be found downstream. Right, and you've seen all the dangers, and you're willing to, say, oh, all right, I won't do all the dangerous things now. I'll just follow very closely in step with you, so I can just see all the goodies and not, step into the wildies. Yeah, so that's the kind of attitude I would C++. I think in 2B is where we'll start looking at some of those quests that will be even more. And I think, it's very fortuitous. I'm spinning the story, and it kind of aligns very nicely with the colors and, the theme, because, Greenland is that uncharted territory. And it's all frozen and cold, and nobody's helping you. And if you skid and fall, you're going to be slippery. Right? So Greenland is a green territory. You're, in the blue sea. It's all deep waters, but still it's the blue sea. So the blue quest, once you're done with the blue quest, I think the green quest, that will take you into that, more dangerous territory. And finally, the red is where you really want to be, I think, right? Where you're not even thinking about C++. I think red is proof, right? When you get to the later quest of red, it is actually proof, not to me or not to the college, not to the state, not to taxpayers, but it is actually proof to yourself that, well, I have learned enough C++ that I am not thinking in C++ anymore. So that is a nice statement to make, isn't it? I think, yeah, I think it's a very nice thing that I thought, because, you only know a language enough when you're not really thinking in that language consciously, you're just thinking. And I think the same can be said for C++. And I think until about the middle of cs2b, you're going to be thinking in C++. And you're going to, and even things that you don't know in C++, you think that you're lacking C++ knowledge, right? But as you progress in cs2b, I find that many students feel that it's not that they have to learn C++, but they just have to learn the C++ way of doing things. There's a very subtle difference between the two. Yes. Because now what you've done is actually use the language as a medium to understand what actually needs to get done, which is the part that is the most difficult for most people, right? And C++ is one of the ways, one of the techniques that tells you, this is actually an easy way to find out what you actually need to get done. It looks hard in the beginning, but it's an easy way to get, to that place where, so, and that is the, I don't know where I was going with that metaphor, but I think that is any language, right? So when you get to that, middle of 2B, that switch I've noticed in students, where in their posts, in the way they're helping other students, right? Suddenly they switch from thinking in C++ to thinking in concepts and using C++ as just another tool, mixing C++ freely with other things they do, right? Regular language, and not having program fragments, but actually using programming stuff in regular language. Right? So you look at the post, you'll see. So this is gradual progression. And when they get to C++, I'm talking about seasoned C++, right? The ones who have actually progressed all the way. By the time they get to the middle of cs2c, they're basically talking only about concepts and problems, how to solve them, logical ways of approaching things, right? And just using C++ as one of the many tools they have, right? One of the major tools they have, but so that is where we want to be. So if you get to the later requests of C++, cs2c, and you're absolutely comfortable, you'll actually feel that you're just using it as a tool to get what you want. And you're not using it as a tool to, not in a bad way, say, right? I'm not using it as a tool to get a piece of paper to get me into this institution, which will get me a goal that is supposed to get me a job that will get me what I want, I think, in about 50 years. Yes? No, not like that. I'm saying, it'll just get you what you want immediately. And so that is where we're trying to go. And hopefully, if you can see that all that we're trying to do as instructors here is be your guides in this adventure, and basically show you the dangerous paths in this incredible adventure you've chosen. Out of, you paid $170 for this ticket, yes, to get in this ride. Now, in this ride, you get a guide who's basically just going to go with you and say, this is the trail. And don't go into the, places where I don't know what the hell is going to happen to you, right? So I can't be responsible. So I just show you, but I don't have any freedom, right? So you could always say, to hell with you. It's a free country. I can go where the hell I want, right? So anybody could do whatever they want. So that is if you say this is what you get for a guide, I don't know. That's enough of a spiel. 15 minutes. Wow. Well, 13 minutes. I'm happy to answer any questions, but today, here's what I'm hoping to do. Not now, 8:30. All right, you guys talk until 8:30. 8:30, I want you guys to take turns. All right, 5 to 10 minutes each person. Take the screen, and hopefully one pack each person. Okay, and you don't have to use the same grammar. In fact, if you use different grammar, that's perfectly fine. Different sentence structure, different adjectives, or different parts of speech, anything, enrich however you want, and you can take time. I think we have enough time. Take as long as you want, really, and talk, and you can draw attention to parts of your program that do things that are interesting, that are unexpected. And because if there are things in your program that I don't notice, or your friends don't notice, or your classmates don't notice, and you don't have time, you should say, no, I want this to be noticed, right? This is something that I consciously built into the program, hoping that it would be really cool, right? Then you shouldn't say, well, it wasn't really cool because lots of people didn't even see it. No, that is like a totally wrong conclusion to make, right? We didn't see it because we didn't get a chance. Or we were thinking about, what I'm going to demo in my program. And so I think it behooves is the right word, I think, I believe, is to say, no, I'm going to draw attention to people, I'm going to pull people to say, hey, hey, I built this really cool gig here. Look at, 15 different faces, right? And tell me, even if you say it's trash, but I want to hear. Okay, so get that feedback. Force people to tell you, and show them different features and say, what do you think? What do you think? So I'm, totally fine. And yank me into the conversation whenever you want. But I am looking forward to basically just being an audience. Okay, I'm not going to participate. I'm not going to. I'll even try and restrain myself from saying that's really cool, that's fantastic. Okay, so I'm gonna. In fact, what I'll do is I'll turn it around. And then I can't see. Okay, so I'm gonna stop my video. Okay, so you can't see my face and mute myself, so you can't hear my reactions either. But I'm going to be watching. And I don't want to bias you in any way or even tell you how enthusiastic I am. But you should feel free to think that I am applauding very loud behind the scenes and you can't see it. Okay, so you should assume that you have at least one person that has appreciated your work. Okay, all right, good. So would you? Well, 8:30. How about 8:30? Well, 10 minutes. Okay. How about 10, 5? You guys feel free to talk. Now, how about this? Okay, for 5 or 10 minutes, I'm just going to turn it around. Maybe I'll just go, 5 or 10 minutes. Okay, five or 10 minutes. And then if I hear silence, I'll come back and then we'll just start the show, right? One person after another. And someone in 2B said it's not the same order for everybody. So someone has to call out your names. Well, hopefully you guys are not jumping around at this point. I'm going to go. Okay, if someone feels they've been skipped over or they'd like to go next or they've left out, let me know. Okay, because sometimes Zoom does this crazy thing by shifting tiles around, and I don't know if I just go left to right, I might miss people. Okay, so not now. When we start, we'll start with this order. Okay, Ashwath, Sean, Keenan, if you're able to go, share a screen, it's fine. Yuya, yeah, you can go today. Yes, you can show.
I'm not up at my computer yet, but next class, I think I should be able to.
Next class is Thursday?
Yes.
Okay, all right, okay. Well, you're an exception. Not everybody gets a chance, just like you, Yang, okay? Except maybe Keenan because he's sick. Okay. Kai?
Wait, is this the thing I shared last time?
Well, you can if you want, but you can, if you haven't made any changes, that's fine. If you use a different pack, if you create a different pack, that's fine too.
I might have already deleted it actually.
Yeah, create a new pack, just
Okay.
create, by the time the first few people are done, you probably have, create, some universe, pick Mario, like, Mario's been done already. Something like that, okay? Who's that Zelda thing? Yeah, I don't know. All right, hey, Noah, can you go today?
Yeah, I presented last time as well, but I can present again if you'd like me
Yeah,
to.
not basketball, okay? So I've seen that.
Oh, Professor,
sure.
Sorry.
Hmm?
I have one question. Do you upload a video yet last week? Because
Hey,
I missed it all the class
you
last
know
week.
what? I forgot to
Yeah.
record it. I'm really sorry. I didn't record it last class. I should have mentioned this or posted it. It's not like I was hoping that it would go unnoticed. It obviously didn't go unnoticed, right? So sometimes, there's only 1 or 2 views on the video, so I think it's not a big deal. That's the reason I didn't make a big, I post about it saying it's missing and all. But since you brought it up, yeah, I'm sorry.
So sorry, because last week I take an airplane, so I'm missing the
Oh,
class.
you did?
So I need
okay.
I
You
need
gotta ask
follow up.
Keenan, okay? Oh,
Yeah.
no, ask Noah or Kai to fill you in. Afterwards, because they were the coders, and I'm pretty sure they know what the hell is going on. Hey, Kai or Noah, can you just
Wait,
fill in?
what did you say I was
afterwards?
last time? A recorder?
No, I didn't record it. Accidental, okay? This time, okay, it actually does say recording. So yeah, all right. Last time I didn't check. Yeah, I'm sorry about that. I'm sorry, okay?
It's all right. I can follow up by myself. Yeah.
Yeah, but I didn't get Noah or Kai to say, okay, they'll help you out, right? Because you just have to say what happened last class. Hey, Noah, can you do that?
Yeah. I mean, yeah, sure. I still don't really understand the whole program and stuff, but
Yeah, that's fine. Don't take time now, or especially since you missed out. Oh, who said you still don't understand the whole program?
I did. You were talking to me, right?
Noah, all right. What about Kai? Kai, do you understand the whole program?
Kind of.
Okay, all right. How about this? Okay, how about this? Before at 8:30, here's what we'll do. At 8:30, let's get the program up. It could be Noah and Kai because they are the two people who have actually committed to saying there's a there's something in there. There's there's some finite amount that they don't understand. Okay, because if you don't say there's nothing, there's something that I don't understand, then the assumption is that you probably understand 100% of it. You don't have any problems. Okay, so we have at least two people who are able to take the screen. Let's start at 8:30. And any doubts anybody has, okay, not just Noah and Kai, anybody has with any aspect of this program, any aspect, okay, up, down, middle, some piece of code, logic, okay, just get it absolutely clear. Okay, this is so straightforward. In fact, you will be able to write this off. If someone rolled you over in your sleep and said, "Hey, give me this program," yeah, okay. Well, you say, "All right, don't just I'll dictate it, write it down." Yeah, okay. So you can get it like that, and it's a piece of cake. So I'll just make sure. I'll make sure. Okay, so let's get that done, and after that we have to do the demo. So today, let's make sure that we start the demos no later than 9 o'clock. Is that possible? Right? We'll just go over the code. Do you think half hour is okay to get solid with the code? All of you? If you think more, that's fine. All right, don't worry. Right? We're just trying to do some rough budgeting here. Is a half hour okay? Initial budget?
Yes.
Okay. All right. So let's say 8:30 to 9 o'clock. Thank you, Jennifer. Okay. Hey, June, are you here? I didn't even hear you because I heard you was switched on his camera now. You here?
Hi, Professor Kumar. Yeah, I'm here.
All right, okay. Great. So I don't know what I was saying. Yeah, all right, so half hour. And then after that, every one of you will just do what we planned before, right? 5 or 10 minutes and just show, showcase. And if people are missing out on something, you draw their attention to it, but make a mental note saying, all right, in my product, I have to somehow emphasize this aspect of that product. So we maybe draw it center stage, right? Move it to the home page or something like that, so you have that kind of, so you get that feedback from people that use your, so that's also a valuable skill to have, I think. All right. So how about this? All right, we got 5 minutes before we start. You guys want to talk for 5 minutes? Yeah, and then I'll be back in 5, and then we'll just pick up the screen. Either Noah or Kai, can you guys just pick up the screen? Not now, okay? At 8:30, can you pick up the screen with your code, and we'll just go over your code? Is that okay?
I'm just coming up with new words.
Yeah, I
Oh
also
yeah, but I'm saying
deleted my.
independent of that, your code. I want to make sure independent
sure.
of the fact. Yeah. All right, thanks. All right, so here's your half hour. Just feel free to talk, chat or something. I forgot what I wanted to do, but there was definitely something I wanted to do. So I'll just go and remember that. So I'll be here. Okay, just call out to me, and if there's silence, I'll come back and start the recording. Start the explanation sooner. All right. Thank you very much, guys. Okay, so just feel free to just talk. Okay, keep the airways occupied. Right, no silence. Thank you very much. All right.
Can somebody send the coding rooms? Because I deleted my last bit of code.
Oh yeah, like the original one.
Yeah.
Right.
Thank you.
Yeah. You get it?
Yeah, I got it. Thank you.
Okay. How do you run the code from the console again? Do you guys remember?
I just remember the first part.
You have to like build it, and then you do like, you run it, and then I think you do a space, and then you put the file or the directory name, like with all the files.
I thought you had to press like make and then the name of your file and then something after that.
Yeah. I just remember that part. Can't remember after. So make lucky and then like G++ something.
Like your folder name, and then I have the line with the while loop. I can put it in the chat.
Nice.
Hey, great. Are you guys good to go? I can,
Yes.
yeah, all right, great. Let's review. Let's do a code review of, I think, what we did before. And anything that you feel that you are not comfortable with, let's make sure that, I think it's also relevant to the midterm. So I think it would be useful to thoroughly understand everything we do here. If I'm not mistaken, we used passing by reference. Yeah, the only thing we didn't use was, wow. Yeah, I think this is actually this pretty much this what we did on last week. Yeah, well, this is great. This is all of it. Okay, I think we pretty much covered all of the concepts for the midterm in this little program. So if you're 100% comfortable with it, I think it's 70% already of your midterm. Yeah, the rest of it is just attention to detail. Just go over your midterm questions and make sure. But conceptually, I think we cover all of it here. I was thinking maybe, we had to have classes and then inheritance. But that was basically muddling up with my cs2b, because there too, inheritance falls on the fringe. For you, it's like it's basic control structures all the way up to objects and classes. That's your second half. And then for cs2b, they start with objects and classes, which they're familiar with, and then objects and classes how do objects in classes now mesh with all the other things that you've learned before? So you've learned X here and you've learned Y here. Now in the first half of CS2B, you learn the product XY. Meaning, how many different ways can I take Y and combine it with X? So essentially, you're going to take these objects and try and play with them in all the different ways your control structures will allow you to. Does it make sense? Okay, that's really the first 6 weeks. That's the first half of CS2B. And then, and just like you're now moving from that to the next level, now they go on to inheritance and polymorphism in the second half, right? Now we're saying, all right, now you know the objects. Now let's see where you can take these objects and start manipulating these objects themselves. That is the second half of, say, CS2B. And then when this is the story, right? And in CS2C, you get to start to solve real world stories and problems using all the techniques you've learned by taking existing objects and twisting them, right? So you get to form these complex sculptures and, by wireframes, by taking the stuff and putting them. That's the fun, I think. Yeah, every kid, when you give them a bunch of Lego blocks, ultimately they have this castle in their head that they want to build with it. So, and getting there is the fun part. All right, let's start with the code and then we can do a code review. Anything in the code that you don't understand, just feel free to ask. And in fact, the better thing would be is if I don't talk about many of these, if before I talk about anything that anyone asks, before I talk about it, if someone thinks that they would like to talk about it, we can either have that person talk about it to everybody, or they could say, I could just talk about it with that person separately offline. That's also fine. Okay, so we can take that off the table. So either of those two alternatives you can consider for each one of these questions. Is that okay with you guys? Just like a regular meeting. Yeah. Okay, great. All right, so we'll just do this like a regular meeting then. All right, so let's start with the code, which is our agenda, and then we'll move through it. Hey, Kai, Noah, who's gonna share?
Yeah, I can go first.
Okay, Noah. No, not first. You're basically just gonna share your screen.
Okay.
Yeah.
That's what I assumed I was doing, but
Yeah. All right.
anyway, what did you want me to show? My lucky.cpp?
The whole thing actually, and if people, and let's go to the top and no, just your CPP file, go to the top. Hey, Noah, are you doing something else now and just doing this on the side?
Say that one more time.
Are you like 100% in this class, or are you doing something else and also doing this at the same time?
I don't really understand the question.
No. So what I mean is that are you having to do two things on the screen at the same time? Because I feel I'm missing you out on a few things here.
No, I'm staying
You're
focused.
good, right? You're in step with the rest of us.
Yeah.
All right, good. All right, so what we want to do basically is in the CPP file, we just go from the top to the bottom, and anything anyone is unsure of, to not in this code, you're going to write something like this, and you think that I can do most of it, but not the last bit. Okay, so you can say, hey, Noah, can you take me to the last part of your code? I want to see what to do there. Okay, and then I don't understand that, and then either Noah or someone else can basically explain that. And if nobody can explain that, I'll also explain that. Okay, is that okay?
Yeah, that's what I figured we were doing.
Thank you. No, I'm not talking to you, Noah. Yes, thank you, Noah. You're going to navigate it for me. Thank you very much for that. You're volunteering. But is everybody okay with that?
I think Jennifer's raising her
Yeah,
hand.
Jennifer raised her hand before too. Oh, is a question, a comment, or no? Thumbs up, Jennifer.
No, I raised my hand.
You have
I
a
have a
question.
question.
All right, thank you. Yeah. All right, go
I'm
ahead.
getting an error on line 17. I'm not sure what the problem is, but it says expected unqualified ID before and token.
Oh, it's a okay. So all right. So this is what is a syntax error that a compiler can catch for us. It is basically if you get the line and if you can somehow share it in a chat, and Noah can just paste it right under his 17, we can compare and see what the hell is different. and see, that's a common mistake, right? So can you
Yeah.
transfer it somehow? Copy and paste.
You want me to just copy paste
Yeah,
line
copy and paste
17
right
in
under,
chat?
right under in a
I
comment. Yeah.
sent it in the chat.
I saw it. Yeah, just put it in a comment and yours. Just line it up with your function, and then we'll see if there's any difference. No, not there. Oh, you want to do it in the chat completely? Okay, all right.
Wait, I'm confused. You were telling me to
No, I'm
comment?
sorry. You're right, Noah. All right, I thought you were going to do it in the non-chat window in a code here. Actually, it's better if we do it in code because the chat doesn't get recorded. It's not on YouTube.
Actually, I think I see, I put string before vector.
Okay, all right.
But
Anyway, so
or just vector.
all right.
Thank you.
No worries. Yeah. That's the reason. Excellent. So like this, however, we should, let's not resolve it in chat. I just realized it doesn't get recorded and it's a pain. Well, let's put it in comments above the code and things like, not from now on, if possible. I think that will help us better. Yeah, feel free to correct me if I'm wrong. Is everybody else okay?
I just felt like if I commented it, then if we commented like every possible syntax error that could
No.
occur in the file.
Yeah. No, that's not what I mean. I mean that, just for the purpose of comparison, you put it up there and then you get rid of it after finding out what the hell is wrong.
Okay.
Anybody else has any questions? Is everybody comfortable with this? Okay.
Yeah, I had a question.
Yeah.
About this part here. So I'm assuming this is like when the file path like can't be found or something, but why can you just apply this like Boolean operator on the object? Is that just like a property of the object, or what's the deal?
So sorry, you asked why can you not apply the Boolean operator?
No, why can you apply the Boolean
why
operator
can you?
to the object?
It's a very good question. Okay, who asked this, by the way? Noah?
Yes.
Yeah, it's a very good question. Okay, I don't know if you guys know the answer to this, right? Because I don't think it is 2A level, but it's simple. It's simple, and the reason it's not 2A level is because it's just simple. You can pick it up anytime you want. That's the reason the state decided not to include it. Okay, it's simple because exclamation mark, plus, minus. What are these? Each of these is an operator. Yes.
Yes.
Okay, now C++ gives you the freedom to override any one of these operators. You can make plus do, string concatenation. You have
Right.
string plus string, you get a concatenation, yes?
Yes.
But it doesn't really make sense arithmetically.
Yes.
But you can say my string class has a plus operator, which functions like this. So you
Okay.
can define a function, and attach it to your plus.
Mm-hmm.
Likewise, there are also operators that operate in unary context, like the negative, minus, and the exclamation mark.
So can you just do that like?
Yeah, you can
just
override the
written in-
function. Yeah, essentially you can override the function. I think it's called a Boolean operator. You can look it up if you want. Okay.
So it's just as simple as like a method override.
Yeah, it's just a method override. Yeah, you just say,
Okay.
this is what my
Interesting.
plus is going to do. This is what my exclamation mark is going to do. And for F stream, they decided this is what my exclamation mark is going to do.
And what does it do?
It checks a whole bunch of things, I think, inside. First of all, sees if the file is valid. Validity, it does validity checks, right? It's a validity
Got it.
checks, and if it passes validity checks, it's going to return true. If it doesn't pass validity checks, it's going to return false. And validity could depend on a number of things, right? Including if the file was opened or not.
Yeah. And then I had a question with this little portion here.
Yeah.
I'm assuming argc is like what we passed in through the command line.
No, it's not. Hey, I can go into detail. Someone else is willing to answer this. This is fine. I can answer that. Or if you want me to answer that privately to Noah, that's also fine. Okay, it's not going to be relevant. But it's very simple. argc is the count of the count is an argc, C for count. Yeah, like stalactites and stalagmites. C for count is the count of the number of words. Number of words, not even parameters, number of words. So the name of the program itself counts as one word. Yeah, so if you
The number of
program,
words in
argc is
what?
at least one.
The number of words in what? It counts the number of words in
On the
what?
command line, on the command line.
Oh, okay.
Like if you go to the command console part, where it says the exclamation mark on the black side, you know, the arrow mark on the black part.
Hmm.
Yeah, go there. Yeah. So you say echo space 1, 2, 3. Echo space 1, 2. In fact, you can say no, no, /bin /echo
Say that one more time.
/bin /echo, which is a program, right? Echo.exe or something like that. Space 1, space 2, space 3. Right. Now we think that 1, 2, and 3 are the first parameter, second parameter, third parameter. No, it's actually, you know, echo itself, /bin /echo is the first parameter. And it is actually in C++, it's a 0th parameter. So everything works out intuitively for us, right? 1 is 1 and 2 is 2 and 3 is 3. But, you know, the name of the parameter is 0. So argv of 0 is your vector. If your array, in fact, we've covered arrays. Yes, it's your array in memory of character pointers, basically memory addresses, where each of these strings that was given, each of these words is stored. So the first pointer is you know, if I got 4 in this case, right? It's 4 strings, the 4 numbers, 4 memory addresses were given to main, along with the number 4.
Wait, I'm a little confused. You said that they're char pointers, but they're pointing to strings passed in?
No, there is no such string as far as an operating system is concerned. A string,
Right.
Yeah, and the operating system is only concerned with bytes in memory, right? So a character pointer is basically what's buried inside of a string. So when I say string and a character pointer, yeah, that's the reason why I maybe shouldn't talk about it this now. But it will make total sense. At the end of cs2a and the beginning of 2b, you'll probably be using it yourself. It's a character pointer is something that's buried inside of a string, right? But it is, yeah, but in C and you know, in native computing, you know, like assembler, you know exactly what a string is. It is an array of characters. It's an array of bytes in memory. You can actually put your finger on each letter. You can actually put your finger on every wire. Well, you can't really anymore. But if you have really tiny fingers, you can actually go in and put your finger on each one of those switches and say, well, this is the N of Noah, okay? And it's stored in memory here. And this is the transistor that went on to, you know, make it an N. Technically, you do that, yes.
Hmm.
And so if you're going to programming in C or C++ even, C++ already you're taken away, right? In C or assembler, you are actually dealing with just memory addresses, and these are your strings for all practical purposes. So your strings are basically just memory addresses, like, you know, eight hexadecimal numbers, right? A, B, C, E, F, 0. Maybe that is a string. But it's not A, B, C, D, E, F. A, B, C, D, E, F is the memory address where you can find the first character of the string. And then, so because argc is 4, you get given 4 such addresses. And the first address leads to a memory location where you see /bin/echo, right? The second address leads to another location in memory where you see 1, okay, the letter 1.
Yeah, I think I get it.
Yeah. So you just get 4 addresses, just 4 numbers. And that's the beauty of it, right? So no matter how many big strings you have, arbitrary length, the operating system only gives you numbers and says, you know, this is where it starts, even though they may be arbitrary length, this is where they start. And when it starts, they will tell you how long they are by putting a /0 at the end. So even that is determined by the user at runtime. That
sounds good. And my last question is, why would we use vectors for our data type?
Which one?
On line 55.
What is your alternative? What else could we use?
I don't know. I was just like, for some reason, like, I mean, like we just used string dir, right? But why did we use vector?
Okay, I can absolutely answer that. I would like for another person to take, you know, probably 50-50 correct incorrect stab at it, and then step in. Even if I say, you know, well, that's not right, you know, but it's and we can try and figure out why that's not right, but was still appealing enough to at least one person to think that was the right answer, right? And hopefully prevent other people from making the same kind of reasoning. Or if it's the right answer, go ahead and answer it too. And I've forgotten the question. Yeah, vector and string. Does anybody want to answer why we have these 2 different variable types? One is called a string and the other is a vector of strings. Come on. Okay, your midterm is in 2 days, right? You got to be conversant with these things. Okay, take a stab at it. Okay, it doesn't matter if it's wrong because you'll use time in your midterm. Well, actually, maybe if you do wrong answers, can you go back and correct the answers in your midterm? I think so. I think so. You can correct them.
Because a vector is a container and a
Yeah, a
scalar
vector is a container. Yes, well, that is far closer to the answer than I had expected. Yes, okay. It is a vector is a container, but list is also a container, isn't it? Why can't we use a list of strings? Or a tree, or tree of
Wouldn't
strings.
you use an array for that?
Why is using an array important here?
Saves time.
Yeah, no. Why are you laughing? Jennifer, are you laughing or someone else laugh?
No, I'm answering, but then I laughed at myself because I don't really know. I'm just guessing.
No. You should never laugh, especially not at yourself, ever, right? I don't think so because I don't believe that there's any stupid question at all. The only questions are that could be offensive or mean questions. So that's perfectly fine. And I'd say it's actually a very good question too. Why isn't using an array important? And because it saves time. How does it save time? Essentially, what we're trying to do is driving along Jennifer's road. Do you see it in your mind? That's all you need to see, right? All we need to see is all 5 questions here, all like ducks in a row. But these ducks are all arranged on Jennifer's road because she is driving towards a solution. But every question she asks is basically refining that notion towards going to the same solution, right? So we started here and saying, well, array. Eventually we got to an array and saying, why is an array important? All right, because it saves time. All right, good. We're even closer to the solution now. Do you understand? Because this is the intuition to get before you get into the midterm, and why we use arrays in certain contexts. Yeah. So why does it save time? Why does it save time to use an array instead of a linked list?
It's faster to read and write.
Why is it faster? Why is it faster in our
Yeah.
use case? Why is it faster to use an array?
They're grouped together.
Well, a list groups together too. A set, for example, a set could also group things together.
So wait, what's your question? Why aren't we using a linked list?
Yeah, why aren't we using a linked list? Why are we using a linked list? Why are we using an array? Why are we using why couldn't we use a linked list or a tree or a set or a bag, some other structure?
Because just why, I guess, I don't know. It's like such a robust structure for
No.
holding-
Such a robust is, hand wavy. We got to get very precise and say exactly why we want to use it. Because once we know exactly why we want to use an array, we will be able to say this is why we want to use it, right? And that's what we want to drive at.
Oh, it uses less space as well.
No, you could still save the same amount of space in an unstructured, bit field or something like that. So there's something about an array that makes it very suitable for exactly what we want to do. If you go to a builder and say, why are you using this particular kind of brick? You could have used any kind of brick. So no, this is the exact reason why I'm using this kind of brick. I could have built it with anything, but this is a reason. So they have a reason and you have a reason too. In my particular building, in this particular program, what I want to do, this is the structure that fits perfectly. Even though I could do it with other things, this is what I exactly want to use. And once you know why you want to use it, you'll know what, every other place, because this is important. And that's the reason why I'm belaboring this, is because this is going to overlap like 1,000,000 times in your life as a programmer. This is what you're going to recur. In your big programs, you're going to have chunks where you're going to make decisions based on this, right? This intuition of why an array is important. Because the array is a fundamental structure. Every other thing is built
sequential.
It's
Because
sequential,
it's
but the list is
sequential.
also sequential, isn't it? Good. Yeah, I like this. I really like this. Right? Thank you, Jennifer. Sequential is good. All right, we're getting closer. But a list is also sequential, isn't it? Yes.
Yes.
Yeah. All right. That's great. That's great. Very nice. Very nice. Go on. Right? No silence here. Right? Take guesses. Sequential. Okay. But why a list is also sequential? So why can't we use a list? A list of strings. Why use a vector of strings? And so we say, why can't we? What is it that we do in this program that would take a hit, right?
I don't think anybody's gonna know.
No, but that's okay. I don't want you to know. I want you to take wrong guesses if you want. Why? So you want to say why not use a list? What is it that you do in this program that's going to take a hit? What is it that's going to do that's going to be inconvenient if you use a list?
Speed.
Speed.
The
And
speed.
why is it that speed is going to be important? I can explain this. All right, let's not waste time on this. But you should totally feel free, just like Jennifer did. You should totally feel free to take guesses, okay? Because even if it's not there, we'll just try and somehow it'll all converge to the same path, right? So the reason is that further down where you actually pick random stuff out of this array. Go to the place where you pick random stuff out of the array. All right. So what are we doing? We're just picking a random number. Right? This is our use case, isn't it? This is the only use case we have. And you should correct me if I'm wrong. We want to pick a random number that tells us, that is between, I don't know, 1 and the number of items in that bag. Yeah, if the bag have 15, right? And then we want to say, give me the 7th item or give me the nth item, some number between 0 and 15. Yes or no?
Yes.
Okay, so that operation, which is going to be done repeatedly, now takes a long time if I use a list as opposed to using an array. Why? Because here is where the fundamental strength of the array comes into picture, right? And this is so important because we know that in an array, every element is exactly the same size, and they're also offset from previous neighbors, right? The neighbors by exactly the same size. I can calculate the address of every element without having to walk to it. Yes? With a list, I have to walk to my element. I have to go to each element and go on, chain on to the next one, until I get to my element. Yeah? I'm going to wait until I hear this,
So you have to go in order, or are you saying with a list you have to go in?
Right? In a list, we are constrained by saying
Okay.
that even though I can store a large number, a huge number of people here, but and I can't know the address of random people. I got to go the first one and find out the next one and the next one and the next one. I got to visit each one of them until I get to the person that I want. Yes or no?
I think this is like a difficult concept to understand if you don't realize that lists kind of involve headers and
No, I'm not talking about headers and nonsense like that. Okay?
Well, I know, but how would you know that lists are linked by items? We haven't really talked about data structures.
Oh, I am sorry. Yes, you're right. Okay, I consider this a primer. Also, I think it's going to help you for your midterm. Okay, consider this a primer for your 2B. But this is basic, and not even 2B. Your week 12, 2A. You're going to be doing this in your last quest, week 9. Okay, this is your linked list. Okay, this is the power of the linked list. The linked list can essentially store arbitrary amounts of information, right? Even nooks and crannies. It can go into, right? Because all it needs is one little block and then a pointer to somewhere else, another nook and cranny somewhere else. So it can basically fill up everywhere. Yes or no?
Yes.
So a linked list has its power. It can just blast out and fill everything like foam. An array cannot do that. So it does not have that power. And yet we prefer arrays to certain things. And the reason is that even though we sacrifice that power, we get something else in return. And what we get in return is that with a linked list, even though we can go anywhere, I always got to start with the gatekeeper and say, you take me there. And that guy is going to go one after another until they get to the destination. That's, you just have to get the, metaphor in your head. You don't have to worry about the code right now or the header and things like that. So is that picture okay with you?
Yes.
Yeah?
Yes.
Okay. All right. So that is your linked list. And you'll implement this later on. And you will see the power of linked list too. Lots of people don't see the power of linked list or the arrays. So this is the individual powers of these two guys. And as linked list says, I can go anywhere you want. It's like the chess. When you play chess, it's your queen and your king. They have the individual powers. The linked list says, if you know how to use me like a chess master, you can wield me because I can get into the tiniest nooks and crannies of the heap, right? However, I cannot do what the array does. Who does not have my power. However, he gives you this incredible power that regardless of where you want to go in that collection stored by the array, right? Even though they can't get into nooks and crannies, if you tell them which guy you want to go to, they will say, you don't have to go through the gatekeeper. You can calculate the address yourself and go directly along the hypotenuse. Yeah, you don't have to go like that. You can just go like that, bam, like that, because you can calculate. Do you see the power of the array now?
Yeah.
So that is why, and we use that repeatedly here, because we generate a random number and say, give me the fifth element, give me the sixth element, give me the second element, right? We do that repeatedly, right? If we generate like 1,000,000 sentences, we're going to do that 1,000,000 times. Yes.
Yes.
And also, one other thing we're leaving in the user's control is the size of these, vectors, or they can pull in 1,000,000 words into adjectives. Who knows, right? So if we have something like that, and then a linked list algorithm, we say, give me the 4 millionth guy, and you're going to say generate 3 million sentences like that. You basically, that program is screwed at that point. So you want to say everything is going to be as ship shape and controlled as possible. And so we say we're going to use a vector which has an array inside of that, which will basically grow like that, but not grow like that. So it has its limitations, but it also has its strengths. So once you know the limitations and the strengths, then you can basically put things together and say, and you can build a big picture by yanking in pieces that will just fit in the right places. Otherwise, you're going to keep jamming stuff in, and it's going to look like mush, right? You've seen programs written by non-programmers, right? So they'll work, but they work like mush, right? So that's what we don't want to do, is to basically understand the power of these things so that you can use them like an artist. So you can say, well, this particular shade of burgundy is what I'm going to use for that part of the picture, right? And so you know how to mix it and get it there. All right, sorry. Any other
Does
questions?
somebody else want to take a screen now? I'm pretty good now.
Anybody else has a question? Or Noah can drive too, right? So you just tell Noah, hey, can we pull up your code and go to line 17 like Jennifer did? You say line 47, right? Is everybody okay with everything else in this code, right? Because I know that there is something with passing by reference with the ampersand before the vec and all, that's like super duper important for the midterm, right? I'm like giving away 8 points or 10 points here, right? But it's like super important, passing by reference. So the ampersand vec, what happens if you leave it out? I don't know if you guys tried an experiment and understand what's going on there. That's like important. Yeah, like I said, we actually used a lot of techniques that in every single class, every single topic that is supposed to be covered, this project actually has in it. So I think I should basically say that maybe I'll turn this into a quest. I don't know, we'll see. Is everybody okay with everything else? No other questions? In fact, we don't have Yeah, thank you. Ashwat's thumbs up. Hey, Jennifer, did you say something too?
No, I didn't.
Sean said something.
Sean said something.
So, yeah, can you hear me?
Yeah, I can hear you.
It's not that I don't have any questions, it's just that I'm like so lost that I don't even know what to ask.
Oh, geez, I'm sorry. All right.
Yeah.
Are you okay with control structures like for loops and while loops and stuff like that?
Yeah.
Right.
Yeah,
So let's just
I'm good
make
with
sure
all
that
that.
you're set up for the midterm. Okay.
Okay.
In the midterm, you got to be solid with basic control structures, for loops, while loops.
Okay. Yeah. I'm good with those.
Precedence rules. All of you. Okay, not just Sean. Anybody else who has questions around this, you should speak up now. Precedence rules. Then you need to know how to write little functions and invoke them. You need to know different ways in which parameters can be passed. I think passing by reference, passing by copy, they're two different kinds. And then with operators, you need to know plus plus and minus minus. What's the difference? What happens if plus plus on this side versus that side, right? So these are the basic tools of the trade that you just need to tuck away already in order to go on to the second part of this class. So if you're not familiar with those, the only answer is not reading. Okay, it's like trade. It's programming is a trade. So you can't read about this. You just have to keep doing this repeatedly. You got to keep programming, crashing your programs. You got to write like your first 1,000,000 programs. I shouldn't say first. In writing, I think there's a saying in English anyway. The first 1,000,000 words you're going to write is going to be trash. So start writing and then tearing up everything you write. And after the first 1,000,000 words, I don't know if that's true and all, but like that, you can assume that the first several programs that we write. We'll basically think are masterpieces, and they are masterpieces in our own eyes, and they should be masterpieces to us. But we shouldn't say that's a masterpiece. I'm going to sit there Okay, so you should say that's a masterpiece. I'm going to create the next masterpiece now, right? And so you should use these masterpieces as stepping stones to go on to achieve, better things. So you start with basic control structures and all these things, and then what else do we have in the midterm? Functions and parameter passing. Arrays.
I'm
Sorry.
still getting an error.
Yeah, compare the code. Yeah, can someone pick
On-
up the code, or even Jennifer? if she
On
can.
line 40. Where,
Hey,
where
Kai
it says
or
int
Noah?
main.
What's on line 40? What's the line? How does your line start? What's the start of your line, Jennifer?
Hold on. Where
you
it
got the
says
code.
int main. I sent it to you.
I'm sharing my screen as well. I think it's this. Her line 40 is my line 42.
Oh, I see. Line 42, int main. And you're getting an error there? I
Yeah.
see. So I bet
It-
that whatever you have above that has some kind of a missing brace or something. That's what I think is going on. You have a syntax error, or more
It
likely a
says a
missing.
function definition is not allowed here before.
Okay, all right, that's right.
token.
Yeah, I think you're probably missing a closing parentheses. Stick in a closing parentheses and see what happens.
Where?
Just before main.
Just before main.
Yeah, like 39, line 39 of, I don't know, is it Noah?
Oh,
Yeah, what? Or do you want me to scroll up a
No,
little bit?
that's fine. Yeah, Noah's line 39. Just,
that created another error that says
what did you share?
expected
Are you able to
primary.
share your screen? Jennifer, are you able to share your screen? We can just take a look at it. That'll be easy.
Yeah, I've never done that, but hold on.
I'm just saying, go to Zoom and say, share your screen, and then make sure you share only that tab of the Chrome window or whatever it is.
Okay, 1 second.
Or if you're going to share your screen, make sure it's full screen, and then you don't have anything else.
Okay, 1 second. Zoom. Oh, this one. Okay. Can you see that?
Yeah, I can actually. You know what? I'll take my change my glasses so that I can see better with this.
I just put
finer
this
size
here,
font.
like you said.
Yeah, no, that's your font is much better now. All right, where's your error? Oh yeah, because you have. I see. You have a parentheses there. Get rid of the parentheses.
Oh,
all right,
you
all right,
told me
wait
to
a
put that there.
Oh no, I meant a curly brace, not a parentheses. But however,
Oh, this was there the whole time.
here, hang on. Let me take a look at this. Scroll up one more line. Scroll up one more line, please. All right. Let's see. All right, there you go. That's all. Good. All right. Your if statement that begins on line 27 is not closed. You see that? You see that open brace? So on line 30, close it.
Wait,
Close
isn't it here?
No.
38?
That is the close of the size t, the function itself.
Oh, I see. Okay.
Right. So
where
close your
should
if
this-
statement. Close your if statement on line 30. No, not there.
Line-
Your if statement closes on line 30. Yes, on line 30.
Oh, okay. Yeah.
No.
Oh, that makes sense.
You're doing that
Okay.
only because I said so. No.
No,
that's
I
not right.
understand because it's before the next thing.
Right. Is everybody clear on this so far? Now, fix your while loop so that it's not indented in and all. Right? No. First, fix your while loop. First, fix your while loop. While loop. Right? It's get rid of the indentation. One level of indentation in front of the while.
Like
Yeah,
that.
there you go. Yeah. It should be understood. And also that if everything under the while, everything that belongs to the while should be one level in. There you go. And then the return should be there. That's good. All right. Now, where is the error? In file included. Now increase the size of your console so we can see what the errors are, and then we'll fix it in like 5 seconds. Okay, don't worry about it. All right, just go right to the top.
Okay. It's a lot.
Read from file was not declared in the scope. Read words from file. Okay, change the name of the line 61. In line 61, it says you're calling a function called read from file, and the compiler is being like super duper helpful to us and saying, hey, did you actually mean read words from file? Although it was really not the compiler's job, if you think about it, right? So it says, you're calling something I didn't know, but it's being like super helpful and saying you actually meant read words from file. So read words from file, not read from file.
For everything.
Yeah, and then I think all of them and compile again, because these days compilation is so cheap that we can basically just keep compiling again and again instead of. All right, now let's go to the top. Sentence equals. Where's that line? Line 76. This is actually useful experience, okay? Even though it may not directly help you midterm, I hope it helps all of you in the midterm, but this is useful experience because this is something that you will do. When your program works, no matter how cool of a coder you are, at some point you're going to write programs that will not very rarely work in the first try, and you got to get to the bottom of the error. This is how you do it. Many people get intimidated by saying, seeing pages and pages of errors and say, no way I'm going to solve all those errors. Yes or no? Because it's very intimidating, right? First time, anyway, cs2a. First time cs2a students compile a program and they see like 5 pages of errors thrown at them by the compiler. Is it common or not? Right? To say, there's no way I'm going to get to the bottom of this, right? How am I going to solve all these 5 pages of errors? Is that a feeling? Because I've had that feeling. I've had that feeling the first time I compiled my first C++ program. Did you have that feeling or not?
Yes.
Yeah.
Okay. All right. So that is like crazy. Okay. And I think that is one of the reasons why in the questing system, I said, when you go to the build messages tab, I say, you're not going to see more than 10 lines. Okay, even though I might get like 5 pages of errors, I'm just going to show you the first 10 lines because chances are 90% or higher that the real problem is only in the first 10 lines. Everything else is a red herring that follows on from that first error. So the best strategy, because compilation and computing is so cheap these days, is not fix anything more than the first 10 lines. Does that make sense?
Mm-hmm. Yeah.
Okay, so never be thrown off by these huge errors that you will encounter in your life as a programmer. Just look at the first 10 lines. That's all. If your first 10 lines don't make sense, well, there's some error. You keep looking until the first error you fix, recompile. Okay, chances are very high that all the other errors were dependent on that error, right? Many of these will go. Now you'll see this, right? You see how many errors? Now we'll take a look at the second one, line 76. Let's go to line 76. All right. Now it says that it wasn't able to do this here. String. Oh yeah. Okay. All right. So why does a string w1? Oh, I see. Get rid of the here the okay 75. Wait, it should actually say 75 itself. No, that's fine. Okay, string w1. All right, put the word string in front of the I'll explain this. Okay, go right in front on line 75. Line 70. Oh, actually, no. On line 76, put w1 inside string, right inside string, and then open parentheses. No, it actually is a string already. String plus what's the error? Let's take a look at it. It's already string. So w1 plus blank plus actually. Oh, it says the error is there. The red. I'm sorry. See.
This is right here.
Yeah. The compiler is telling us where the error is, and we're not looking at it. So there's, all right. You can get an empty string there somewhere, and it says this is an error. But by the way, let's fix that also. It shouldn't be an empty string. There should all be spaces. Are there spaces? That one should be a space. All right. Plus adverb. No, it should not be adverbs. It should be adverb. Okay. It's and then verb. It's because you see on line 69 to 73, we're selecting individual components. Yes.
Yeah, oh, I see.
Yeah, and we're stitching them together. So now you see there's only one noun 2. Where's noun 2 is missing? Oh, you're not picking noun 2. Just copy and paste. Triple click on line 71. Triple click on line 71, and don't do anything more. Right now, is this a Mac or a PC? It's a Mac. Command C.
Yeah.
And then hit 2 Command V's. No, you actually missed out. All right. So hit enter there. Command V one more time, 2 times. Yeah. All right. Now change noun 2. All right, now you have 2 nouns, yes?
Yes.
Now it'll work. No, you see, name of direct. All right, so it works, and then if you give your package name, it'll work. But I think this whole experience was actually, thanks to Jennifer, a very useful experience for all students. Yes or no? Please correct me if I'm wrong. Okay, so this was a very useful experience in debugging your own programs for all students. Yes or no? I don't know. Nobody seems to agree, but I think it was
Yeah.
useful for me, Jennifer. Okay.
I would say yes.
It helped me. Thank you.
All right. Anyway, I liked it very much. All right. So I thought it was useful, and I'm going to point future students also at this video, saying, there's a program, and it throws lots of errors at you, and that's not like C++ with bouncers, heavy duty bouncers at the door, kicking people out. You're too shabby for my club. No, it's not like that. It's these are. They throw a lot of stuff at you, but they say, don't worry, man, just to look at the first few lines. All right. That's where the real message is. Everything else is basically, stuff to scare the riffraff. Right. So for real programmers, they only need to look at the first 5 lines and they'll be okay. Because if you're really interested to come in here, just look at the first 5 lines. That's where the password is. And then you can come in. Right. Other people will get scared off as they should be, because they won't last inside. Right? If you're not scared off and you know the trick, then that's exactly the same trick. Exactly the same trick that we used in getting to the root of Jennifer's problem here. You see how we had these pages and pages of errors, right? And just by focusing on the first few lines, everything went away, just like that. And it's exactly the same approach and mindset that you'll bring to bear even on your programs, because what you're going to do is your program totally does not behave the way it wants. Now it runs and compiles. Okay, we got past the compiler. The big boss, right? Not even the ultimate boss like Ganondorf, right? The middle stage boss is not your compiler errors, right? These are your mini bosses. Okay, so the big bosses inside are your logic errors. Logic errors the compiler can't catch. Like no, it says, I'm fine, everything is fine. Just give me a package name and I'll run. Yes, but your logic errors are stuff that's hiding there the compiler cannot see. Yeah, and to tackle them in the second half of this class, that's a new challenge. Okay, so you got to be completely comfortable with your mini bosses, because they're going to be coming at you like that, right? So you got to be vanquishing them in your sleep. Then you can face the big boss, with 100%. So get rid of all of your concern with these guys. Compiler errors should be history, right? Because even if you face compiler errors downstream, because they're never going to be absent in your life, right? Even if you're a top programmer in a top company of your own, right? You're still going to have compiler errors. So you're not going to live with the compiler errors. So rather than say, I'm not going to make compiler errors, just see them as a part of your life, and develop an automatic response saying, well, yeah, fine. The first time I'm going to have a compiler error. In fact, you should look forward to compiler errors, because you can do careless programming many ways. Because you can do careless programming. I don't know, it's a strategy worth teaching cs2a. Careless programming is basically using a programming language as your way of spitting out pseudocode. Does that make sense? Okay, because you have an algorithm in your head, like Shakespeare's play, all right? It's just bursting to get out, right? And it doesn't care. It just has to come out somehow, because it's there. And you got to spit it out. And English is too slow, or even logic or mathematical symbols. And you say, you write it out, and then you got a very good companion to help you, right? You can spit it out in pseudocode in C++. But your pseudocode in C++ itself will be good enough for the compiler to say, you can just make a few fixes here and there, and it'll be a proper program. Yeah? I don't know. Okay, so that's careless programming, careless productive programming, right? So you can basically just use the programming language as a medium as a paintbrush or a canvas to express your thoughts, and then your compiler will be your friend, and it'll just point out places where you need to fix it up with red ink. And say, well, now it's a complete finished product, right? With your vision. And so that will happen once you get past compiler errors and treat them as friends, rather than red ink thrown at you to keep people away. No. It's actually red ink thrown at you to give the artist a way to be free of these things. And say, you don't have to worry, man. I'll tell you with red ink what, the places where you go and fix up things, right? You do what you have to do. I'll take care of this, red ink stuff for you. That's a good attitude to develop for compiler errors, and see how really cool that is. And that's exactly the same attitude inside of logic errors too. You say, when I make logic errors, what I'm going to do, where was I going with that? I don't know. We'll get to it at some point, okay? But it's the same mindset. How you attack a compiler problem is exactly that's the approach you're going to bring to bear on a logic problem in the second half of your course. You're going to say, in my logic issues, right? I'm essentially going to force my program into certain corners where I know its behavior, right? Because if you have a program that logically works fine, but doesn't work in certain conditions, right? The first thing you do is explore those conditions yourself and find out all the nooks and crannies and say, okay, well, I know this, I know these are the hardships that person will face. Now I'm going to let that person in there and see what the hardships they face are, okay? Because this place, I know how they're going to behave. If they behave other than what I expect of them in this area, then I know that's that's bad for them. I got to pull them back and say, wow, all right, okay, I got to build this safeguard into you so that next time you go in there, you're not going to kill yourself. Yes? Yes or no? We're not even talking C++ here, right? Assume you're building a robot, okay? A robot that has to explore the nooks and crannies of a mine-filled battle area, okay? So it needs to go and navigate and find out, and mark the places with flags, okay, where there are mines, landmines, buried landmines. It's exactly the same, isn't it? Same approach. So you're basically going to say, all right, I don't know where I was going with this metaphor, but essentially, yeah, it's a logic errors. You're going to say, you're going to map out the terrain in small part. You can't map out the entire forest, okay? But you'll map out some small part of the forest and say, well, in this forest, in this small, 1 square kilometer area, 1 square mile area, I know exactly where the mines have been planted, okay? So I'm going to let some robots in there and make sure that they don't, they're able to do the right thing without getting killed. Isn't that how you train a robot? Yeah. Suppose you bought robots today, yeah? Isn't that how you do it? I don't know. That's how they train rats. Okay. So I saw a YouTube video in which in Afghanistan they trained rats, desert rats, to sniff out landmines, and they're so light that they don't set them off, but they plant flags in there so that they can go and dig them out carefully. This is really cool, isn't it? So, but if you didn't have rats, right? But that's how they trained rats. I don't know. How do you train a rat? To go through a maze. I don't know. I've never actually seen one, even though I was in the psychology department at Johns Hopkins. Never actually went. They had these experiments, right? So how do you train a rat to? So what they do? Well, I'm pretty sure there's YouTube videos. But basically, that's what you do, right? You in your logic errors, you do exactly what we did here. We're going to say in here in my logic space, I can't do the whole thing, but I'm just going to take 10% of it. All right. And in here, I know how the program is supposed to behave. So what I'll do is I'll just create a very careful map of this area and I'll let the program loose in that area and I'll see if it's behaving exactly as I think it should. And that part you can trace with your debugger. Okay. There are very sophisticated debuggers, not just Xcode and VS Code and things like that. You can go all the way down to the level of individual machine cycles at the kernel level. Right? You can if you want on most systems. So you can see exactly what's going on and you can say, right, this part. Okay, this program, according to this room in which everything is scripted, everything is predictable by me. The program is not doing what it's supposed to do. That dance that I had choreographed for it is not happening here. Okay, so exactly, because you can't tell that if it's out there in the million square mile world, it's very hard to debug. Yeah, so you only debug it in that. So that's what we did here. Okay, so we can't look at all of the compiler errors. We just look at the most important part. And likewise with Joel. And once you have that intuition, you'll bring the same thing to bear in logic errors, right? And you can bring the same thing to bear on spatial structure errors, right? That you build a spatial structure and right? That's the way to prevent bugs in spatial structures, right? Or that's the way to prevent bugs from data sampling, because you can get incorrect inferences in machine learning systems if you feed it the wrong kind of data, right? So you got to make sure there are no bugs in data, because some data bugs are very misleading. They can lead people to a lot of wrong conclusions and also convince them in all kinds of ways, just because the sampling was wrong. Right? Sampling was drawn from a population that was incorrect. So that kind of thing can be avoided. And it's all good for the AI, isn't it? The AI should be trained on absolutely, equitable data, right? On what is really happening, so it can form the best decisions for humanity. And that's why all of this is all going to be so super duper important in the future, I think, anyway, right? Not maybe in the immediate future, but very soon afterwards. So does that answer all of your questions? Because this is all important stuff. And I think that thanks to Jennifer, we have this fantastic opportunity of not a rehearsal, actually a play in which we met a beast, right? We met a beast and did not run back, which is our natural reaction. When we see a beast, we run back. That is our natural reaction as humans, yes? And what I mean by a beast is that when you compile your first program, no, I'm not talking about hello world and things like that, right? What's the worst possible thing that, if you hash include, your compiler may print like 5 pages of errors. I'm talking about when you try and do something that actually does something interesting and useful like this, and you see a whole bunch of errors, okay? That is like a beast that says, you know, what the hell are you guys doing here? Doing professional grade software, right? This is guarded by the territory of terrible beasts, right? You come here again, we're going to rip you to shreds, okay? So that's what the compiler spits out at you. And you think, well, you know, those guys, they got professional .exe programs that people, that's what I used to think. When I was a kid and Microsoft DOS came out, I was always and I knew that I could write these .batch files, right? Programs that would behave like real programs, but you know, you can actually see them and all. And I used to look at these .com and .exe files and say, well, they're actually executable programs. And then I got to know that you can actually create them, the .com files using Norton assembler or something like that. You know, I was like super jazzed up, and like that with this, you know, this whole idea of you know, programming. I don't know where I was going with that. But essentially, thanks to Jennifer, that we had this opportunity to enact this when we saw this beast and said, you know, I don't have anything to fear from this beast, right? All I need to do is just pat it on its head, right? The top 10 lines, and then it yields to me and says, hey, what do you want, right? Basically, that's what I want, you know. Say, the beast says, you know, and if you do that, I'll be your pet, right?
Professor?
Yeah.
Can we go over F-stream again?
Yeah, sure.
Yeah.
No worries. And I want to say before we start that this is not in the syllabus, but it's not. In fact, it is not even in the syllabus. Okay, it's I don't think F-stream and things are tested in the midterm.
Oh, it's not.
Or in the
Okay.
final even. F-stream essentially is basically what in C. It basically borrows from the operating system, the research we've done so far, which kind of is drilled into Unix and DOS and all these other operating systems we use. What we do when we read and write to the external world. Here's a CPU inside of this, the CPU inside of my laptop. Yes, that's a CPU. That is the guy that needs to read and write everything. Yes or no? But if you stay in step with me, I'll tell you what F-stream is, okay? I'll give you a really deep appreciation of F-stream, right? So well, let's start here. This is my CPU. This is the person, right, that is going to execute everything for me. That is the CEO of my computer. Yes or no?
Yeah.
All right, a chief productive user. All right, something like that, CPU. Now, in order to get this done, all right, so this guy needs to interface with the external world somehow, if they are going to be useful to us and if the external world is going to be useful to us. So this is the relationship that this guy wants and that the external world, that meaning us, right? So we want to be able to interact with the CPU and get the CPU to do stuff for us. And we can also imagine, right? The CPU wants to interact with us and do, right? We'll inject some kind of, let's anthropomorphize. And I think that's a word for it. Anthropomorphize the CPU, saying the CPU wants to get stuff done and needs to talk to us. Okay, all right. Now, the CPU knows in its infinite wisdom that there are like an uncountable number of different languages out there that it needs to speak, right? Because the external world is filled with so many different ways in which, you know, beings interact. So it knows that, you know, all right, I can't deal with all these different things. I can't talk, you know, Mandarin and English and, you know, Martian, right? Or binary or, you know, continuous radiation. It says, right, here's what I'm going to do. I will talk one language and I will call that a socket language. Okay. So it's basically going to give you a socket. Okay. And to the socket, it'll say, I will talk to that socket using ones and zeros. Okay. And I will know how to talk to the socket. And that is called a stream. Okay. That socket is called a stream. And it could either be an input stream or an output stream. I will know how just to talk to the stream. Okay. I know only one thing. Okay. Anybody who needs to interact with me, just take what the stream gives you and interpret that in your own way. So if you're a rover on Mars, all right, read from my stream, okay, and interpret that in rover language. If you're an AI algorithm in China, okay, read from the same stream, right? But you know, so essentially what I'm going to do is basically say I can only read streams. So what I want to do is I will get a stream from China that will basically say, you know, you plug your bits and bytes here, I'll spit out Mandarin. Okay, a stream from rover that says you plug your bits and bytes here, I'll spit out you know, Roverian or Martian. Okay, so I don't need to care. all I need to know are you give me device drivers that can drive the device of your choice. I don't care what the device is. It can be a continuous device, an analog device, digital device, whatever the device is, right? I don't care. All I need to know is I know how to interact with that device in one way, and that's the only thing I know. Does that make sense? So that is called a stream. And there's two kinds of streams. One is called an in stream and there's an out stream. Now, the stream that the operating system gives you when your program starts, it gives you 3 streams, pre-manufactured, prefabricated, so that when your program starts, it's ready to go out the door, talking to humans, okay? And these 3 streams are console input, which is a stream that is connected to your keyboard. Yes? I don't know, I feel
Yes.
like I'm
Okay.
talking to myself.
No, I'm with you.
Yeah, okay. There's
Yeah.
another stream, all right? That is an output stream that is connected to your screen, and that is C out, console out, right? C in, console out. Yet another stream that also connects to your console. We won't go into the details. That is called the error pipe, all right? The output and error both go to the stream, but one is colored red and one is colored white. Let's put it that way, okay? Black and so 2 streams, CERR going out, COUT going out, C in coming in. Okay, these 3 streams get given free for you, meaning that even though there is an overhead in the system operating system manufacturing it before your program starts, yes, because nothing is given to you for free. You know, if you get a stream, you know, someone put the effort, some CPU cycles were burned in manufacturing the stream to give to you. Yes or no?
Wait, say that again?
So when you start a program, you automatically get these 3 streams given to you. It's like going in a Target or, you know, and buying, let's say, washers, you know, the Home Depot, or buying washers for a particular, you know, nut that you got. Okay. It's pre-made and it's available. I don't know where I was going. It's streams. All right. So, but the thing is, maybe you don't need the streams. Maybe you don't want to communicate with the user at all. Maybe you just want to wake up, right? Increment the system clock and die again. So you don't need streams at all. Yes or no? You can write a program that does not need to interact with the user. Yes or no?
Yeah. Yeah.
All right. Okay. So now the thing is, every time your program starts, every single program that starts will get those 3 streams for free, whether you use it or not. Okay. It's like going into Home Depot, and whether you need a particular washer or not, it's going to be there because it's just pre-made. Why? Because lots of people use it. 99% of the people just buy it, right? They have a need for it. So 99% of the programs that people write interact with users using these 3 streams. So whether you like it or not, you're going to get them for free.
You don't need IOStream for those?
The IOStream provides C in, C out, and C error. Those are the 3 that are provided by IOStream. Among other things. So IOStream is what contains those for you. Yes or no? Is everybody okay with this so far?
Yeah.
Yes.
All right. Now, where does F-stream come in here? Now, F-stream is not given to you for free, okay? Because it doesn't know which file you want to open and read and write. Yes? However, it says, you know, we know how to deal with streams. There is a library out there that you can call to that will also open files and treat them just like consoles. Okay? And if you ever want to use files like consoles, just use F-stream instead of IOStream, because IOStream talks to the console, F-stream will talk to a file. All right, but however, when you hash include F-stream, this is subtle differences, not in the syllabus or anything. It's just reasons why, you know, computer scientists have done it this way, and just so that we get a much better appreciation of these things, right? So just by hash including F-stream, you don't automatically get F in and F out. Whereas by hash including IOStream, you get C in and C out. Yes?
Okay.
Just by hash including IOStream, you get these 2 objects that were, you know, manufactured and given to you for free, and it's in global space and standard space. However, by hash including F-stream, which is its counterpart, but talks to a file, you don't automatically get F-stream and, you know, F out, which are, you know, in standard space. You have to create that, I think, in line number, I don't know, whatever that is. Somewhere in there, you actually say IF stream and then the name of the file, right? And that says, right, now it's time to create a file stream. Here is a file to which that stream should be attached. Go ahead and create an input stream from that file, all right? And you give it the file name. So in that case, you say F stream up there, but actually create the stream in your program when you say F stream. Does that make sense, right? That is the only reason you just get C in and C out for free when you start up. It's been done already for you in global space. F stream you have to do yourself, and you're doing that here, right? F in is, you can call it anything. You can call Sean file input if you want. We just call it F in so that it kind of maps to C in. Does that make sense? Sean, you're looking puzzled.
Like how?
You take
I
your
don't know.
time, take your time, take
Yeah,
your time.
how did you create the FN?
Hmm?
Like I don't understand like how that.
Yeah, go
It's
ahead.
probably
Right?
like
We
line
have
20 and
time.
line 23, right?
Yeah, we have time. We'll go over everything. I want to make sure that everybody is comfortable 100% with this program. Okay, everything we do in this program. Right. What was the line number again? Sorry.
It's like line 20 and 23, right? Creating FN.
Oh, all right. Yeah, I see it. 23, F stream.
23.
Yeah.
Yeah,
F stream is our line in the program that says, give me a CN, except this special CN. I want to call it FN instead of CN. Okay. And I want this to be a file stream, not a console stream, right? So it doesn't need to be attached to the console. It needs to be attached to a file, and it needs to be attached to a file called this thing, called path. We've said all that in that one line. We say F stream, F in, path, right? F in is what is called a constructor for the F stream. F stream is an object you will define, right? In a couple of weeks, you're going to define objects. F stream is a class, okay? It's defined by the system. And F in is an object we're creating that belongs to the class, okay? And then we're saying, construct that object using this file as a parameter. And that file says this is the endpoint to which that stream should be attached. I don't know if that makes sense. Okay, now I'm glad this is on, being recorded, because I know you're puzzled, okay? And you don't have to figure out unravel this puzzle right now, but you need to bookmark this, this moment or time in YouTube, and come back to it in like a couple of weeks. And then you won't be as puzzled, because F stream will make a lot more sense to you. Right now, I don't know. It's not going to be on a midterm, and it maybe even doesn't make much sense to you because you haven't done classes. Yeah. Do classes first, okay? Do classes and constructors, and then come back and look at this statement again, line 23 of this, right? Don't worry about line 23. Just assume. Put a comment there. Hey, Noah, can you put a comment there? Maybe on the.
I'm not the one sharing screens.
Oh, you're not. Right. So anyway, this is what should happen. Okay. What that says is that let's magically assume that Fn is going to give us a counterpart of Cn. Let's magically assume the previous line gives us a counterpart of Cn, except that this Fn, within quotes, is attached to a file whose name is path. Okay. And the reason for this. Oh, I see. Oh, Jennifer. Is this Jennifer?
Yeah.
Oh, all right. Yeah. Let's type it in. Let's magically assume that the above statement gives us a counterpart of Cn, right? On the next line, continue the comment that the Cn, whose counterpart is attached to a file instead of the console. Right, and the next line. And this file lives at the end of, I don't know, this file is named by is named by the variable path, Yeah, I think that should do it. And in fact, this whose counterpart, let's put a parenthetical or F in right there so that they know what the counterpart is that we're talking about. F in is the counterpart of Cn. So we need to say F in is the counterpart. So after counterpart, say comma. After counterpart. Yeah, okay. Fn is the counterpart of Cn. Fn is a counterpart of Cn. And we are making it. And the previous line manufactures it. And the previous line manufactures it. All right, is that self-explanatory enough for someone? And also we should add a comment that this is not necessary for, until, this is not necessary to be understood until after we've covered classes in week 6, week 7. So that people don't spend 3 hours trying to understand that and then skip out on, miss out on the opportunity to master the rest of the stuff, which is important for the midterm. Yeah. Anything else that is, confusing to you? We have time, right? We have time until, it's only 9:36. You guys can carry on a conversation if you want. You know what? You guys should be demoing your code. Well, we can do it on Thursday too. Who else can go today? Is everybody else okay with the code so far? Right? At least Thursday, we should basically just all do demos. Okay? Everybody does their own pack, including Noah and Kai will do their own packs. Okay, not basketball, and Sean also, not Mario. Okay, do something else. Okay, everybody will get a chance. Just do their pack, and also try your own variation of sentences too. It doesn't have to be noun, adjective, or whatever that is. Right? Try your own. Pick your own words. Do your own pack, and then we'll create a whole bunch of packs and say you can run this program lucky with any of these packs. Okay, one program, many packs. Okay, all packs created by w22 students, and that'll be fun. Yeah, something that we can play with. Yeah, all right.
What does string : and POS do?
Yeah, sure. Right, can you pull up the code? Anyone, can you pull up the code?
Yeah, I can do it. Hold on. Can you guys see it?
No, one sec. I can see it. Yes, I can see it. Yes, thanks.
Okay.
What is it? What is it that you wanted?
What does this do?
Oh, I see. Did we put a comment? We did put a comment. You see that line 26?
Yeah.
Yeah, string : npos is basically a special variable. It's defined. You can put a comment on even on line 20, line 30. Line 30.
Okay.
Put a comment on line 30 also. That says this variable is defined, I think, in string iostream.h or some file included from it. This variable is defined in string.h, which is included from our iostream.h. I think so. I think so, right? I'm not sure. Does it make sense? Sean, is that okay?
Possible. Oh, okay.
Any other questions? Everybody okay so far?
Look at the while loop on line 34.
Is that you, Justin?
Yeah.
But most of you have, are rectangles, especially in the YouTube video, there's just going to be gray rectangles and we can't even see. And when you speak, I just saw it was Justin because, the highlight, I can't even see the rectangle, right? I just hear a voice sometimes.
I think I understand what all of the commands do separately, but I'm not sure how they fit together and do what they do.
All right, so how about this? Why don't we take this, right? We have time. Why don't we take this and let's just go through it step by step and see what you don't understand, and we'll see what we can do. All right, so just why don't you take over, okay, what you don't understand, and then we'll try and explain it.
Okay, so while getLine finLine should be, it makes a string out of fin and the line from the path, right? From the document.
Okay, so here's what it's going to do. Okay, so we let's not call it fin, although that's my hesitation before in choosing that variable name, right? It's an English word. It's fin. It's like cin, not sin. And cin is fin because it's an input stream that comes from a file. That way, it's a whole lot more intuitive what it does. So fin is a stream that is attached to a file. GetLine is a function that looks at the stream that's given, whether it's cin or fstream, it doesn't know. Yes, it just knows that it's been given a stream, and it has been given a variable by reference called line, Okay, reference means it's a container that can hold something. It needs to pull something out of the stream and put it in line, and then say I'm done. Okay, and get line, the word means that the programmer who wrote get line wrote the function such that the thing it's going to pull from the stream is an entire string that is ending with a /n, which is a new line. So what gets put in line is an entire line. So when getLine returns and says, I've put something in there, not false, true, it means that line contains the next line from the stream, which is actually attached to a file. Is that helpful?
And it's taking it from the read word or the nouns.txt or whatever. version
Yes,
of the text.
yes, that file that we just opened before, right? So if you go, 2 lines up, Jennifer, is this Jennifer or who's got the
Oh
screen?
no, this is me. This is Sean.
Oh yeah, Sean. Right. So 2 lines up where you say f in path, that is your nouns.txt, right? So the previous, you see that for each one of those paths /nouns.txt is where path is in a path is your directory /nouns.txt, directory /adjectives.txt. So you get path can take 4 possible values, and we're going to iterate through each one of those, right? And each one you're going to open the file, attach it to the stream, read from the stream, stuff it into a vector. That's what we're doing, right? Very simple process, and you're going to do this like 1,000,000 times before the end of cs2c. Even before you leave Foothill College, you're going to do this so many times. That's why it's so important to spend as much time as you possibly can to explore every single nook and cranny of this area. It's so simple, but it's also easy and interesting and important, because you're going to be doing this so many times. It's better to just relegate it to your subconscious. Is everybody okay with this so far? Right? Reading from a file and stuffing it into a vector. Okay, basic operation. And in fact, this is going to be like a 1-line idiom you're going to do unthinkingly when you start digesting information from in data science, tons and tons of information into a vector from a file. How are you going to do that, right? And sometimes you just want to suck in a package and then do a 1-line Python command that's going to crunch it for 3 hours and spit out a number. Okay, you're going to write 3 lines of Python statements. You just have this massive terabyte data file, right? And then some interface to a Python model or some model on Amazon or cloud, Google. And then you have a prompt like Jupyter or something like that. You're going to type 3 lines of Python. You're going to fire up this massive program. And all you're doing is exactly this. You're instantiating an object and you're giving it a file name. And you're telling it, this is what I want from the file, get it and give it to me. Does that make sense? So it's a standard loop. The standard loop that you'll apply, same paradigm over and over again in many different ways. Reading lines from files, reading floating point numbers when you're dealing with matrices and images. Yeah, same, exactly the same. Reading from a file, stuffing into a vector, right? And reading, into a vector that is eventually given to something else to process downstream. That's also possible. So, but reading from a file and stuffing into a vector is a basic operation, right? It's like a dance, right? In dances, you have these complex choreographed sequences, but if you break it down, you see that many of these are individual, 3-second or 4-second pieces that have been practiced like millions of times by the performer, right? In different contexts. So they know how each of these work. They know the various beginning points and the end points, and they can take many of these and stitch them together so that when you look at it end to end, it looks like one continuous performance, one story, right? However, these are individual parts taken and, the ends have been whittled and to fit so that it looks like one path, but they know how to go from here to here. And when, one pose ends, they know exactly that the end point is the starting point of the next pose, right? So they fit everything together so that it looks like one seamless continuum, but it's actually just fitted in. I don't know if that metaphor even makes sense, but that's how, when you get the intuition about data and how these pieces fit together, all you need to know is, why a file input output. There's different ways I can do it. And this massive project that has file input output occurring in 8,000 places. Okay, so these are different ways in which this could fit in. You just say, okay, well, like that. Okay, you can even have a program script how files are going to be instantiated. So it's all pretty standard stuff, but it's also useful to know. And spend a lot of time. I think the first 6 weeks of your entire C++ journey will actually lay the foundation for how enjoyable the rest of it is going to be. Because you spend a lot of time and effort now getting all the basics out of the way, you'll be able to enjoy what it really brings to you, instead of fretting around with the basics when you should be enjoying the higher level stuff. right? I see a lot of cs2c students even who are struggling with basic concepts, and when they shouldn't be. They should be enjoying the ice cream, not how to get to the ice cream store. All right, do you have any other questions? Do you have anything else that you want to ask?
Why do we return vector size instead of
Yes, very good question. Thank you. Who asked that question, by the way?
me?
You can't say me, okay? In fact, some of you, like you have has lips covered. I can't even see if it's moving, right? So, so you have to give me some indication. Who said me?
Justin.
All right, Justin. Okay, thank you. Very good question, Justin. Okay, technically speaking, you don't have to return vector size. You can just say void. Okay, so and in fact, if you remember, if you go back to the video, I think when we designed this function first, we started off with a signature that says void. Okay, it doesn't have to return anything. But later on, we thought, well, we can get the size for free anyway, right? If we had to calculate the size, it makes sense. So just say void. Yeah, but we're getting it for free because vector automatically calculates it for us, right? It's not going to calculate the size. It knows. So you're going to get it for free. Why throw it away? We'll give it, pass it on. And if they can make use of it, they can let them make use of it. If they don't, they can toss it. Yes? Is that a reasonable strategy?
Yeah.
Okay. That's why we're returning size t. Does that make sense? And I think it's a very good question. Okay, so these are the questions that really you should ask in the forums, and also someone else can give the same answer that I did. But I don't know if you can find this kind of answer elsewhere, even on Stack Overflow, right? But these are the kinds of real decisions that software engineers make, right? Not not run-of-the-mill software engineers, right? I'm talking about seasoned, proper ones who have a solid intuition about program complexity and economy of CPU cycles and thought, right? These are the ways they think, and it's not really codified anywhere. And you can only pick this up over years and years of experience with of working amongst a lot of people that are giants. Okay, you have to be immersed in amongst them and seeing how they work and see how they think and saying, wow, all right, well, I used to do it this way and this guy's doing it this way. Why the hell is he doing it this way? And first of all, most of the time we don't even think, why is that person doing it differently? This is the right way to do it. Why are they doing it this way? Right now, and many people don't think that. And then I think after a certain while, humility sets in and say, well, there must be a really good reason why they're doing it that way, even though I don't do it this way. This is a real good reason. And that guy's intelligent, right? So let me give him the benefit of the doubt and see why he's doing it that way. Then we start looking at why they're doing it that way. You say, wow, okay, I didn't even think this was possible. All right, no, I can do it that way too, right? And then you start doing it that way. I don't know if you come across situations like that. But these are things that you can only pick up by working in, after you start working. You have to find a place that's not like your run-of-the-mill startup, where you can be amongst people that in the know. And then you can see and observe them, and also observe them with humility and saying they're doing it differently, not the way I'm used to, not the way that my masters told me how to do it, right? Not the way that even the best person that I know in computer science that person does it differently, right? So either that person is stupid, or they probably have something interesting to say. So let me go and find out. It takes a long time for us to say, let me go and find out what the reason is. Right. And once we get that, we say, it's exactly the same thing. They're all doing it different ways. But let me find out all the different ways this can be done. And I think that's where we need to go. And all of this is really standard stuff. I don't know how we got started talking about that. But essentially, this is all there is to it, really. Midterm is a piece of cake compared to what you'll be doing downstream. But this is time well worth it. Is everybody okay with this? Yeah, like this question about Justin asked why return size, and that's nobody can give you a valid answer. The only answer anyone can give you is has to be rooted in actual programming experience in real life out there, because otherwise there is no justifiable reason why in our application it should return .size. Yes or no? Yeah. I don't know, right? So some of you are in 2A. Maybe you'll know when you're in 2B. 2B also, you'll also have a lot of classmates who are actually professionals in the field. So you will be able to relate to them and relate to the subject in a different way. But you'll see that these are actually valuable nuggets you can learn from other classmates and other people, especially after you start working. these questions you can are very valuable. That's why I want to see them on Reddit rather than here. How many people will take the time, right? Rather than some future AI that's going to index all this and find out these snippets. If you're going to be valuable immediately right now to people that want to learn computer science, burying it in a video is useless. It has to be out there. You have to ask these questions, Stack Overflow, right? Or Reddit, where other people can ask and give you reasonable answers, right? And I'm pretty sure if you ask this in Stack Overflow, someone will say, some half-assed programmer who doesn't know what they're doing, who hasn't been in the field long enough, they just know the theory of it and say this is how it should be done. I'm pretty sure you'll get a lot of answers and downvotes and things saying, you shouldn't return. If you're not going to use it, you shouldn't return it because you'll end up confusing a programmer. This is what the rule says, right? Now, who cares a shit about the rule, right? We just want to do something that makes good sense. And so you'll see a lot of people actually give you good, sensible answers too. It's free. Why? And you're not going to use it. Why just throw it in the trash, right? And you have these dumpster drivers drive, I think in California anyway, right? So there are people that actually take the trouble to go to Trader Joe's and Whole Foods and so on, and they go to the dumpsters and they dig through the dumpsters and get food that is past the due date and dumped by Whole Foods. But not past the expiry date, or they have some method to calculate that, right? And they give it free to homeless people. And this is really top of the shelf stuff. That's that companies have to toss. So like that, we can feel free to. I don't know where that analogy fits in, but I think it figured somehow. Anyway, that's it. Unless you have any questions, we should.
One more thing.
Yeah, go ahead.
One more thing. What does vec.push_back do?
All right. So vec.pushback. Yes, thank you. Vec.pushback does a number of things. That's why it's just one function. Again, maybe we should use a comment. All right, put a comment there, Sean, on line 37. Right. Pushback is a magic function that is attached to the vector class. For now, okay, magic function. I put for now in brackets. Right, and then next line, let's say for now, assume that pushback will take. For now, assume that pushback will take the variable line and push it at the back end of the given vector, of the vector called vec.
Assume that the pushback would take
the variable whose name is line, the variable, or say comma line or whatever, variable comma line, and then comma again, and next line, and push it at the very back of the array housed inside the vector named vec. All right, it's a really complex way of saying it, but I think it makes total sense. I hope it makes total sense. Does it make sense?
Hold on. Pushback is assume that pushback will take the variable line and push it back at the very back of the array housed in the vector named vec.
Anybody who does not understand this should feel free to ask now. Okay, it's all like important. However, we'll get a chance to understand this deeply after week 6 because the dot notation and calling methods attached to an object, we haven't covered that. Okay, that is the vec dot is a notation that will only come after we've talked about objects. So don't worry. That's why I said for now, right? So ignore the vec dot stuff. Put a comment after that saying. I think that the reason for Sean still being hesitant is go on to the next line for comment. You say ignore vec, ignore, and then within quotes saying vec dot something, right? Within quotes again, as this is object notation we'll cover after week 6. Is that okay? Is that better? Not in the midterm, okay? Not in the midterm, but you have to be familiar with these things. And are the comments in this code, in fact, you should just put this code somewhere and share it with everybody, maybe on the Reddit, and say, here's a link, people can go and copy this code so that people can review this code, ask any questions about it if they read it, other people can answer it. Okay. Especially questions like Justin asked, much better asked in the forum and someone giving a real answer, right? If someone had, let's say Keenan had the same answer that I did. And if you asked in the forum, Keenan could have given that answer in text form, and it'll be a permanent record. And it's actually very valuable for students to have snippets and nuggets like this in their portfolio, right? Because if Keenan said, this is the reason a professional engineer would actually use that, even though that makes good sense, right? That is something that a hiring manager would greatly value. Says, this is not just a person with theoretical knowledge, but also knows the ins and outs of what is actually costly, what is not costly, what makes sense to give someone else, like dumpster drivers, right? We're not going to use it. Let's just give it out. Maybe someone else can use it. That's the reason. And if Keenan said that, and a hiring manager will certainly follow that person's progress, right, on LinkedIn or whatever it is, and say, hey, maybe we should get them into our company. You'll get good internships. And so that's why I say, if you have interesting questions, save them up, and only the questions that actually resist all attempts by classmates to find answers, bring them to class, and we'll talk about them in class. And then you can bookmark them in YouTube videos. But personally, I would prefer that we imagine that the past Reddit does not exist. Okay, the Reddit only exists for talking to your current classmates. You can ask current classmates questions. You can post questions that ask answers, even though answers already exist in the past. But we should not look at the past. And also, you should give your classmates as much opportunity as possible. Okay, this is the way you can help each other, because I can only help you for 3 months, right? I get a batch of students and they have to move on eventually, right? I can stick with you so this is the way you can help each other. And the way you can help each other is by giving each other opportunities to shed pearls of wisdom. Okay, ask questions just like Justin did, and imagine what a great opportunity it would have been for someone else to give the same answer and say, that's a really valuable, nice answer. Now it's totally lost, right? For humans, anyway. So ask as many questions as possible in the forums. Don't care if people in the past have answered these questions. Just ask so that someone else can say, here's the answer. Don't look at the past. Here's my answer. And then you'll get lots more points, lots more recognition, lots more opportunities. People will seek out your talent and say, come and work for us. Do this for us, okay? And I have lots of projects, right? I have lots of projects going on in nonlinear media, interesting and useless projects, okay? And if you're interested, I can absolutely, after you finish Quest 9 of cs2c, I can reach out to you and say, yeah, you seem to be really cool. You want to try a hand at this, right? So, and if you're interested, you can do that too. And things like that. Are you guys okay with this? Are you happy with the midterm? Are you confident? Are you confident of facing the midterm and going on to next? Really, the next week of cs2a is the next chapter, right? It's not like just one more week. First 6 weeks is different in all of my courses. Maybe not 2C, okay? 2C is difficult from the word go, okay? But you won't find it difficult. If you finish 2B, you won't find 2C difficult, right? People who find 2C difficult are the ones who didn't do 2B properly. They just passed and then got in. But 2C is difficult from 1, okay? 2B and 2A, okay, until quest number 4 at least, okay? So I don't want you to feel, and also you have to remember one more thing that I think I just discovered. I didn't know until now, that in 2B, quest number 4 is really, really hard, okay? 5, 6, much easier, rewarding, nicer, and give you some breather too. But unfortunately, I think this might have happened to past students and I didn't pick up, is that people try quest 4 and it's really hard, and they think that I can't cross quest 4. How the hell am I going to get past 5 more quests? They're all going to be harder or even harder. I'll make this clear in the syllabus also. No, not like that, okay? Some quests are hard, but once you get past it, you'll get a breather, okay? You'll get some easy quests too. Does it make it easier? Because I think that a lot of people are just put off by seeing a really hard quest and saying, there's no way I can make it through the entire course. Yes? Right. So if you find some quests hard, just imagine that that's hard, not the next one. Okay. I think it'll see you through, and we're all there to help you. STEM Center, fellow classmates, the forums, also, us instructors too. We all check the forums. We're available for, one-on-one consultations also is perfectly fine, right? It's like office hours too. I think some students in other classes have felt that they're not getting enough office hours. And in my class, that's why I said in the syllabus, right? There's no limitation. I have infinite, unlimited office hours. Anytime you want, as long as I'm not already teaching another class, right? Or in a meeting, I'm happy to give you an office hour, as long as it's by arrangement. And also, it should be stuff that is not generally useful, right? So it should be stuff that, it should be say, I'm stuck here. What kind of things that you think can help me, right? I'm more than happy to walk you through some problems and say, I give you a sample problem, watch you work through it and say, well, that's why you're getting stuck there. Okay, so these resources will help you, right? I can pinpoint exactly what you need to study in order to get to the next level. So, and I can do that, 24 hours a day, really. I don't care, right? Even if you wake me up. So that's available to you. I want as many of you to get to the complete, the completion line, right? Not 2A, all the way through. And make a name for yourself, do something really cool. And it's past time already, so I should really be keeping you. And thank you all for just sticking around. I know you have other classes also, so thank you all for sticking around. Thursday, we will do a dry run. I want all of you to come. Okay, don't be absent on Thursday, and no waffle on Thursday. Okay, as soon as we start, 8:15. If you're not here by 8:15, we're not going to wait until 8:30. 8:15, the first person will start. Let's start with Sean. Sean, can you go at 8:15? Because you're here on,
sure.
On time.
Yeah, sure.
Okay, and it's not going to be Mario, okay? Do something else.
Okay, just a new
so,
pack.
Yeah, whatever. Do something else, and maybe even fiddle around with the sentences, right? Don't have to use noun, adjective, and try a different kind of sentence structure.
Okay.
All right, so Mario will go first, 8:15, right? And then you're all going to go one after another, okay? Noah, not basketball, and so on and so forth, and one after another. I'll call the names out. And you'll all get a chance, and we'll start at 8:15. If you're late, you'll miss out your chance, okay? And maybe I'll even give some extra credit or participation points out before your demonstration there. Okay, you never know. I don't know. So I encourage all of you to come back and participate, and I hope you're having a great time. Okay, I don't want you to just do this for credit. Okay, I want you to do this to master the material, because you can. You can do this, and that's why I'm pushing you. Right? If you can't do that, I'll say okay. And I'll just give you an easy freebie. Okay. But I know you can, so I'm going to keep pushing you. All right. Thank you very much for your time. If you have any questions, just feel free to reach out to me. I hope this was all useful to you. Right? We did go over some part of the code today. Sean? Yeah? Was this all useful to you guys generally?
Yes.
Yeah.
Yeah.
Okay. All right. Next class onwards, you should not let me talk so much. Yeah? And hopefully early on, one of you should take the code and start coding, and I won't have to talk so much, right? At least the last 6 weeks, I can watch more of you coding. Yes or no? Is that okay with you guys? Don't let that put you off from not attending. Okay, you should attend class. If I got to talk to make you come, I'm happy to talk. But my preference is that I don't talk. I'm the audience. Okay, because you need to take actors in plays too. Sometimes they want to sit in front of a couch and sit on a couch and watch a show, right? They don't want to be actors all the time. So you should give me a chance to also watch you guys code, because that's what the pleasure for most instructors come to. So if you go to math also, right? So maybe math people don't tell you that, right? Sometimes when you get invited by the instructor, math instructors say, all right, here's the theorem, prove it on the whiteboard. They're not testing you, right? They want to be in the audience and actually see. And say, take a break and sit down and watch someone else walk them through the proof and say, hey, there's another way to do it too, right? So those are, we should, and unfortunately many students look at these as opportunities, as places where they're being tested or evaluated. It's for $170 or whatever it is that you pay for community colleges. And you're coming here to think that you're going to be evaluated, that's, that is a waste of your time and effort, and also the wrong conclusion, right? You paid money to get to know things, and that's the right attitude, right? Come here and grab as much as you can, and to use it to enrich your life. And I think you'll be very happy with yourself for that in the end. It's midterm time, so I have to give you a little bit of pep talk. But I think next week we'll actually start coding heavy duty. Okay, we'll start coding with objects, classes, feel totally comfortable, we're going to use a lot of the constructs we've used so far, unthinkingly, right? And then hopefully, I really, really hope we don't spend a lot of time when we're coding. It's okay, right? When we're coding something and you have a fundamental question, right? And then unfortunately, I will get sucked in, okay? I will get sucked in. Even when we're doing advanced stuff, you ask a fundamental question, I may get sucked in and waste like 10 minutes talking about this, this thing here. And we have to minimize all that. And the way to minimize this is just by staying step with me, right? And just type, sometimes I've seen Keenan or some Noah, for example, right? Typing a few steps ahead. That's perfectly fine. Okay. And next week, I think most of the students will be comfortable with that. And if you're not comfortable with that, you just get back to me, right? And say, or you can say, slow down a bit. Okay. You can say slow down a bit. That's fine. Or you can say it many times, but you'll say that, you say that 10 times, 15 times, you'll see that you start saying it less frequently, right? And then you don't need the person to slow down. Right? Everybody's happy to slow down, but they need to be told to slow down. And and hopefully we'll also minimize digressions and things like that starting next week, because we don't have to. We can actually start looking at real content. And by the time you're done with 2A, you'll be waiting for 2B, right? Now unfortunately, I'm not teaching 2B next. You'll be waiting to do the questing for 2B anyway. You can do Mikhail's 2B and then come to my 2C in spring. Or you can do my 2B in spring. No, actually just do it and do Mikhail's 2B. If you want to do 2B. How many of you are planning to do 2B? Raise your hand. No? Only some of you are, oh, I see. Well, only one person is actually interested in continuing on in cs2b, the series. If you're interested to do I would recommend just try Mikhail's and do questing on the side, and then come to my 2C and get credit for the questing also. And you'll be set up for 2C. Is that okay? Thank you. Was that useful? All of you guys? Yeah.
Yeah.
Then thank you all so much for your time. Thanks for sticking around, right? Even after class and all. I have a meeting later today, but if you need any help, just let me know. But my preference is always keep it public and open to everybody. Good for you and for others. Okay. I'm not saying nobody's evaluating anybody here. Just make all the posts that will be useful for you.
All right. Thank you.
All right. Bye.
Thank you.
Oh, thank you.